Excel has a ton of formulas, but you don't need all of them to get really good. In this video, I'll walk you through the most useful ones, from if to filter and from count to XLOOKUP, only easy to follow, super practical, and things that you'll actually use. Let's get into it. First function we will cover today is if. If helps you make decisions with your data. You provided a condition and it will return one value if the condition is true or another value if the condition is false. It's great for flagging things such as this is above target or this is below a threshold or this needs review. Let's look into an example. So in this dataset I have the track names, the artists, the albums, the release date of the songs, the popularity in a scale from 0 to 100, as well as the duration in minutes. Let's imagine that we would like to understand if a song is generally popular or not. We can create one more field here that we will call popularity level, and we can use if to decide that. We can start by typing if and then pressing the tab button, and then Excel, as it does with all commands, provides us with some syntax support. As we can see from the pop-up, we firstly have to provide the condition that will be checked, and then the values that will populate this cell in case this condition is firstly true or false. In my case, I would like to check if the song has a popularity score or more than 70. So I'm gonna highlight the respective cell, then I'm gonna specify the condition, and then I'm gonna say that in case this is true, I will call the song as popular, otherwise not popular. And then I'm gonna close my brackets. Press enter, and you see already that this has a score of 75, so that means it satisfies the condition and the song is popular. When I click here, the function will propagate across the full table, and we can see already here that this song, the Blinding Lights, is supposed to be not popular since the popularity score is below 70, according to my definition, of course. But specifying just a single threshold to say that the song is popular or not might be a bit of a black and white approach. What if we would like to be a bit more flexible? For that we can use ifs. Ifs is like an upgraded version of if. It can take multiple conditions without the need to nest a lot of if statements, one within the other. It's cleaner and easier to manage. Let's look at it. We can create a new column that we will call popularity level 2. So I have to start typing ifs and then the tab and then specify the first logical test that will be evaluated, then the respective value that will take place if this test is true, and then we will move on with the next conditions. So we will say here, for example, that if a song has popularity more than 80, then it is a very popular song, and that's the first condition. But then we have the flexibility to enter a second and a third and a fourth condition that will be evaluated only if the previous condition was not true. So if we know that this song will not be above 80, then we can say, how about above 50? So let's say that if the popularity is above 50, then we will call that just a popular song. And what if this condition is also false? Well, we can move on with specifying a third condition, such as that the popularity is above 30. And in this case, well, we can say that this is a somewhat popular song. And finally, if this is not satisfied again, then we can say that for any other case, for example, if the popularity is below or equal to 30, then we can call that an unpopular song. So we close our brackets, press enter, and then double click to propagate the function. Next up, IFERROR. The IFERROR helps you handle messy formulas by catching and handling the errors. For example, in this dataset, I have some categories of products, and then the profit that they generated, the sales, and then the profit margin. And as you see from the formula here, this is really the ratio of profit divided by sales. But what happens if the denominator of this formula is 0? What happens, for example, if we're missing one value here? As you see, the formula now will break. And in order to handle that in a graceful way, we can make use of the if error. This will help us define how the formula will behave in case of such errors. As an example, we can start typing again the formula like this: equals if error, and then the value that will be there if no error is encountered. In our case, it's again the profit divided by sales. And then we can add the value that the formula will return in case of errors. In my case, I just want a blank cell, and I can do that like this. I can close then the brackets, press enter, and when I drag this down, you can see that the percentages where I actually had the values remain intact, while where I was missing the value, we now have just an empty cell. Next, we talk about three similar but also different functions: count, COUNTA, and COUNTIF. The count function does exactly what it says. It counts numbers. It only works on numeric values, so it's great for figuring out how many valid entries you have on a certain column. On the other side, COUNTA counts everything. It counts dates, texts, numbers, everything that is not blank. So you can use it when you want to know how many rows actually have any kind of data. Finally, COUNTIF lets you know how many times a condition has been met. For example, you can count how many entries are above a certain value, or how many people have answered yes to a survey. So here I have a dataset with order ID details, customer ID details, customer name, and the quantity, so how many items were sent with a specific order. So what if we use count on this numerical column, the quantity? We can start by typing count, then highlight the column, press enter, and well, it says that there is 21 rows that have some kind of information. And indeed, if we highlight all of those, we can see from the bottom right side that they have 21 as the count. But now what if we apply the count function on the C column that holds the customer name details, a text column? Let's find out. So you can see that it returns 0 because all those cells are text values and not numerical values, as before. Now let's do the same test, but using COUNTA this time. I'm gonna apply it first to column D, and we can see that it returns 22 because it counts actually all rows within this column, including the header, because COUNTA counts everything, while count before was counting only the numerical values, as we said. What if we apply the same function on column C this time? What do you expect? Well, you guessed right. As we said, it counts everything, and it returns 22 again. Now, what if we would like to understand how many of these orders had more than 4 items? Well, there is a condition in there, and we can use COUNTIF to make it work. I can start by typing COUNTIF, and then I have to specify the range where the condition will be evaluated, and then the actual criteria. The range for me is column D, the quantity column, and the criteria is, as we said, more than 4. And then we can close the brackets and get the result that there are 6 orders with more than 4 items. Next, we're looking into 2 string functions, CONCATENATE and TEXTJOIN. CONCATENATE helps you combine text from different cells into one. For example, let's say you have 2 columns in your dataset, first name and last name. You can put them together in one field using CONCATENATE. On the other side, TEXTJOIN is even smarter. It allows you to combine content from different cells, but actually include a separator or even skip blank cells. Let's look into an example. In this worksheet, we have 2 columns, the first name and the last name of the client, and we can combine them in one in this new family name column, like this. Typing concat, then specifying first name, and then last name with the cell references, then close our brackets and click enter. Now I can see that both strings came together here in one, but I would still like to have this extra space between first name and last name. I can add it in the formula like this. So what this does is that it will firstly take the content of cell A2, then add one space character, and then the contents of cell B2. When pressing enter, we get the updated name, and we can drag the formula down. Now, as a second example, imagine that you would like to combine more than 2 strings. Especially if there are many, things can get complicated. For that, we're gonna use TEXTJOIN. So here I have the country code where the order took place, its year, and one order number. But what I would like to do is actually create a new order number that combines all this information in one. And I can do that by typing TEXTJOIN and look at the arguments. Firstly, the delimiter, so the extra character that will come between the contents of all those cells within one row. And in my case, I just use the hyphen delimiter, like this. Then, as a second argument, I have to decide if the function will ignore empty cells, if any, or include them as well. In my case, I don't have empty cells, so I can go with either. And finally, I have to specify the cells that the function will calculate on. In this case, I can just drag and drop this and select all these three, close my brackets and press enter. And as you see, I now have my new order number that combines all these three pieces of information. I can drag this below as well, and here it is. Next is the unique function. It returns a list of the distinct values from a cell range, not duplicates. A great use case for it is returning the unique list of the customers or the products from a sales dataset. This is a video game dataset, and in column A we have the different titles of the games, while in column B we have the different consoles for which they released. What if I would like to understand what are the different consoles for which I have games in this dataset? What I can do is start typing unique and then highlight the column or the cell range that I'm interested in and press enter. And here you have it. We can see that although this dataset has around 200 rows, there is only 12 consoles for which we had games in it. Next, we have the filter function. It's great for extracting data from a cell range which fulfill a certain condition or meet some criteria. Let's see an example. Within the same video game dataset, here I have the titles, the consoles, and the genres of each one of the games. What if I would like to extract here only the rows for which the games were released in the console PS4? We can use the filter function for that, like this. Start typing filter, then the array within which we're searching, in this case columns A to C, and then the criteria that should be satisfied. And in our case we said that console, so column B, should be equal to PS4. And then we can close our brackets. And here you have it, a part of the original dataset on which you can do any kind of further analysis. I hope you liked it. If you found this helpful, like, subscribe, and comment below. See you in the next video.